Grade 12 Science, this is a lesson about the derivation of the impulse formula and also the definition of impulse, and also it involves Newton's second law. So let's start with Newton's second law and the formula being F net equal to ma. Now acceleration is by definition the rate of change of velocity. Therefore I can replace the delta V with Vf minus Vi over delta t, then multiply the m in. That gives me m Vf minus m Vi over delta t. But mass times velocity of a moving object by definition is the momentum of that object. So mass times final velocity will be the final momentum minus the initial momentum over delta t, and that brings me to delta p over delta t. Therefore, if we just bring that down, F net equals delta p over delta t means that we've got a second version of Newton's second law, and that is where the momentum, the rate of change of momentum is equal to the net force acting on an object. Now, if we then multiply this formula with delta t right through, then we will get F net delta t, which is equal to delta p. Therefore, we have a new quantity, and that is called impulse. Okay, grade 12s, now that you know what impulse is, let's look at what the definition of impulse would be. It is simply the product of the net force acting on an object in the time that it reacts. So it is F net multiplied by delta t equals delta p. And then I also want to just go back to the previous form of Newton's second law, like that. And then there's a lot of applications that you actually need to take note of when you see this form. Now, if we look at specifically cricket, and that's the first one that I want to talk about. If you think of how a cricket ball is caught, you usually catch it with the hands brought backwards, and in that bringing backwards of the hands, you actually extend the time of impact. Therefore, if you make the denominator more, you will actually have a smaller net force acting. The other one is airbags. In airbags, we get the airbags deploying when there's impact on the front of the car. Again, the passengers will hit the airbag and the time is increased. Therefore, the net force acting on them will be less. The other thing is arrestor beds. Now, arrestor beds are also covered in your textbook. Please look at that. You can also think of tennis. The reason why tennis rackets are replaced often in big tournaments, again, you don't want the time of impact to be too long, because then the net force acting on the ball will be too small. They also have to replace the balls often for the same reason. Then that's about it for the Newton's second law in terms of momentum. So I just want to conclude by saying that you need to read the question carefully. When I say give Newton's second law, you give the old Newton's second law, which is when a net force acts on an object, the object will accelerate. The acceleration is directly proportional to the net force, and the acceleration is inversely proportional to the mass of the object. All of this then combines to the F net equal to ma. And remember that then the other form of Newton's second law is the rate of change of momentum. Now, the questions don't always say that you have to use force and time to calculate impulse. You need to remember that impulse is F net delta t, but if you don't get the net force and the time of impact, then you can work with the rate of change, then you can work with the change in momentum. And for change in momentum, remember, you just need the mass and the final velocity and the initial velocity of an object. So they won't always say calculate the change in momentum. They just ask for calculating impulse. You need to remember that these things are equal. That's all for this lesson.